Hello, everyone. My name is Simon Shah. I'm a sales architect of InterSystems Corporation. In today's demo, we're going to be showing you how to leverage the InterSystems Kubernetes Operator to achieve auto-scaling with your compute workload inside of the GKE Kubernetes environment. So what you're looking at right here is a GKE cluster that I have set up. Within my node pool, I have currently 2 nodes running, and auto-scaling is set to scale up to 5 nodes for the increased workload. So I used the IKO InterSystems Kubernetes Operator to spin up the Iris cluster running inside of this GKE cluster. So let me quickly go through what IKO is and how do we use it. So IKO is a orchestrator of the InterSystems Iris container deployment within the Kubernetes environment. And you can define your deployment topology all within a single YAML file, which is you're looking at an example right here. This is my example YAML file within which, this one here, within which you can define secrets like for Iris license. You can define secrets for image polling the containers. And under the topology, I currently have a data container, which in InterSystems ECP concept, this is where your Iris instance contain all the data storage resides. And it's using Iris for Health 25.1 container. And you can also define stuff like mirrored, true or false. And in the cloud, you can define preferred availability zones to achieve high availability for your mirrored pair. There is also a web gateway, what we call a sidecar web gateway container to be included in the same pod. And this is the compute node, which we're going to be working with for our demo. The compute node does not require any Kubernetes persistent storage. Basically, it does all stateless type of work. And in our example for today, it is to perform XSLT transformation. As you know about XSLT, it's quite resource intensive based on the size of the XML documents. It can be very heavy. And when the CPU when the resource is limited, you can really, it can really slow down. So, and in in real life, in the healthcare environment, the XSLT workload is mostly unpredictable. Just think about on a Tuesday morning, you all of a sudden have, millions of CCD documents coming in that will really mess up the performance. So to solve that, we have a section in the YAML file to define horizontal pod autoscale, and within which we say, oh, give me 1 minimum pod and upwards to 4, and the scaling is based on the CPU utilization currently set at 40%. Okay, so you can do a lot of things with the IKO, and here these are only a few examples. So now let's put things in action. I have a simulation that simulates 3 concurrent XSLT transformations of SDA to CDA at the same time, and we'll let it run for 5 minutes. The other thing I wanted to mention is this file that I showed you earlier is actually a service defined for a load balancer. So when you have more pods coming up for the compute nodes, in Kubernetes, it's very easy to create a load balancer to point to all the compute nodes so that the workload can be evenly distributed between them. Okay, so I'm gonna start my simulation. Okay, and it started. Let's go to my environment and put a watch on how many pods we have currently on only 2 pods for compute-0 and data-0. In a very short time, we're going to be seeing some differences because the workload has been added to the. So we can also have the take a look at the let's see, get HPA. See where we stand at the well, right now it's 21%. We have 1 replica running at this time at the moment. So let's give it some time and see. Oh, okay. So something's happening. I have a new compute node, and it's being created. It has to create the web gateway and the Iris container. So it will be a few seconds before you see them fully up and running. In the meantime, let's put a watch on the HPA and see where we're at with the so that's 434% has been reached at the moment because of all these XSLT transformation requests coming in, hitting these compute pods. So after the compute-0 was created, now the compute-2 was added to the party as well. With all these new pods join the party, each takes a portion of the workload. I would expect the average CPU utilization gradually come down as more and more compute power got added to the system. So if the node is no longer if the node pool is no longer have enough nodes to accommodate all these new pods, Kubernetes in the GKE will provision new nodes, and there'll be more cost. But the beauty of the things is, after the increase of the workload decreases, you give back the pods, and you give back the nodes. So in that particular moment, you actually save, have some cost savings. That is, nice. That works out nicely in the cloud world. So if you wanted to have any further information with the InterSystems Kubernetes Operator, please feel free to look at our documentation or send me email for more questions about this demo. By the way, Kubernetes, it dropped down to 163%, which is exactly what I was expecting. And Kubernetes is kind of, conservative, getting rid of these pods, so that it doesn't accidentally lose any work. So we're not going to wait for that. And this is the end of the demo. And thank you for watching.